Hi everybody, welcome to the first section in pre-calculus. Most of the section that we'll study here come from Gaussian algebra or trigonometry. So I will go over the first few sections rather quickly. So function and relation. Relation is corresponding between two sets. So if we have x in the first set and y in the second set and they are related, we're going to write x to y. So in this case, we say that x corresponding to y or y depends on x, and we write x with an arrow to y. So an example, this is we have the first set that have some state names, and then on the second set we have some numbers, and then there's some association. For example, Mississippi associated to 4, or we say Mississippi correspond to 4. So that would be, according to this, this will be the number of representatives in the House of Representatives. So Mississippi has 4, Florida has 27. So of course there's the correspondence between the two sets. Right. We can write the relation as order pairs, at the set of order pairs. So like Mississippi relate corresponding to 4, Louisiana 6, and then so on. The first set in the order pair, the set of all the first component is called the domain, and the set of all the second components of the order pair is the range. So if we have this relation, all the first components put together is the domain, all the second components put together is the range. Definition of function. Let x and y be two non-empty sets. Function from x into y is the relation that associates each element in x exactly one element in y. So we can see here we might have two different x values that go to one y values. That's perfectly fine. What we cannot have is that we have one x values that go to two different y values. We cannot have this. So we might have a bunch of values of x going to the same y values, perfectly fine. But we cannot have one x values. We cannot have one x values that go to two different values of y. We cannot have that. Right. So each one in x will have a values in y. If they choose to, they can go to the same y values. Many different values of x go to the same y values, but not one x values go to two different values. That is not accepted. Right. So here we have some example. For each relation, state the domain and range determine whether the relation is a function. Right. So domain would be the set of all the first component. So domain for this function, the set of all the first component, 1, 3, 9, and 2. And then the range, the set of all the second component. And we only list once, 5, 1, 3, 5, and 9. I can even sorry. 1, 3, 5, and 9. The range 5, 9, 1, and 2. So is this a function? Well, 1x, 1y, 1x, 1y, 1x, 1y. So yeah, so it is a function. So I just say it is a function. Right. Next, write the domain and range here. the first component 2, 5, 7, and 1. And the range is the second components. 6, 5, and 5 again. We don't need to write that. We have 15. So here we have 5 and 7, both of them going to 5, but that's perfectly fine. We might have different values of the domain that give to the same values of in the range, but that's perfectly fine. This one is still a function. Right. Next. The domain. The first component -5, -2, -5, -2, 3, 2, and -5, which we already have. So we're not going to write again. Then the range. One, 2, 3, -2, and -3. Right. Is this a function? Well, this is not a function. It is not a function simply because in the domain we only have 4, and each one of them have to go to one of those in the range. Since only 4 and there's a 5 in the range, one of those guys have to associate to 2 in the range. And it is what we have here is we have -5 that goes to 1, and we have -5 go to -3. Because of that, it is not a function. A function cannot have one value in the domain, gives 2 values in the range. So that's why it is not a function. Of course, when we look at the numbers, if 4 of them can only give to at most 4, but since we have 5, one of those guys have to associate to 2 in the range, and because of that, it's not a function. Right, so that's good. Next, determine whether this equation represents y as a function of x. Well, now just think about this. If we have one value for x, put in here how many values of y do we have. And if we do that, I think we only have one values, because when we have one x values, we only have one y values. So it is a function. We'll just say y is a function of x. Yeah, because one x values only give one y values. Right, let's continue. Determine whether this equation defines y as a function of x. Now, let's try to solve for y and see what happened. First of all, we can subtract 6x to the other side, right? So 3y squared equal to move the 6x over -6x plus 2. And then we can divide by 3. And then we can take the square root on both sides. Just note that when we take the square root on both sides, we have to put plus or minus. Yeah, so you will see this again. So that means when we have one value for x, we will have one y that is equal to positive -6x plus 2 over 3, or y equal to -6x plus 2 divided by 3. So since we have one value for x that corresponds to 2 values for y, so this is not a function. because we cannot have this, right? Yeah, because the function cannot have one for x that gives two values for y, so it is not a function. So I want to write a note here. In general, if we have y square or absolute values of y, potentially we may have plus or minus. So that's why I'm just going to write this in the note. When there is y square or y raised to an even power, or we have an absolute value of y, we will have plus or minus like this. Because to undo this, we have to take a root, and even root we have a plus or minus. And in that case, most likely it's not going to be a function of y in terms of x. By the way, on some extreme case, we don't have the plus or minus, but as we just said, we usually, because there might be some extreme case, it still work. So y is not, so we usually, it is not a function of x, because if we have y to an even power or absolute values of y, to get back to y, we have to have the plus or minus. Therefore, it's not a function of x. Like I said, usually it's not going to be. It's not going to be always. Right. So more on function. The values of function. The restriction of this input and okay. When I type the note, I forgot to write the graph. So pretty much. It is kind of the machine like this. There is an input and there's an output, and this is kind of like a function. So whatever the function is, when you have an input in, it will have only one type of output. You cannot put one input and let's say if this is a machine only do one kind of things, one certain type of cake for example, then we put all the ingredient here, it will give us that kind of cake. We cannot just put the same ingredient and then we have different type of cake here. Yeah. So it accepts only numbers from the domain. From each input there's only one output. So if we have all the ingredients for one kind of cake put in the machine and it will give you that kind of cake, we cannot have the same ingredient and it gives you different kind of cake. That's not impossible. That's not possible. So that is think of other function is like that. Right. Some more terminologies. X is called the independent variables because if we can take any values in the domain. So it is independent. The variable y is called the dependent variable because y depends on x. X can be chosen independently, so that's what we said, independent variable, and y depends on x. And in the independent variable is also called the argument of the function. Right. Next, we have an example of evaluate function. This should be easy. Just get used to how would we evaluate a function. By the way, if we do it by hand, f of x plus f of 3, f of x is going to be 2x squared minus 5x. So there's nothing new here. And then 3, we're just going to put 3 in it, and we're going to combine the function. So 2x squared minus 5x. 2 times 3 squared, that's 18 minus 15, so look like 3. Right. Another way to evaluate function, this I would recommend if you have a calculator like this. Right. So first we store into x, and then we have 2 x squared minus 5 x. It is better to type the function and when we have the value, so that is 3. Right. Similarly, if the function is x squared, what is f of 1.23? Of course, we can just say 1.23 squared, or we can store into x and then evaluate. Since there's only simple, just x squared, so we're just going to say 5.29. Right. Now, this example, I just need to show you where the x cube is on this calculator. Sorry, the calculator did not display properly, so let me do this again. First, on this one, 3 store into x, and then we can enter the function to x squared minus 5x, right? And then we have this. If we want to just store into x and then do x squared, but since this is just one number, just x squared, I just say 1.23 square. That. Now, for this one, I just want to show that where the x cube is in that calculator. So, in math, and the cube root is here. If we want any higher root, of course we can go back and change to 4 if we want to, but yeah, it's 3. Cube root of negative 2.46, and we have that negative 1.3499. Yeah, simple enough. Next, we have implicit versus explicit forms of a function or equation. So usually when we say implicit, it could be a function or equation. But when we say explicit, it is a function. Right. So the difference is, in general, a function defines the equation of x and y. So when we have the equation, it is not necessarily a function. So that is in implicit form. So if it is possible to solve for y in terms of x, if we can write y in terms of x, this is a function and it is in explicit form. So we have some example here. 2x plus y equal to 4, x squared minus y equal to 7, and x times y equal to 5. Those are in implicit form because this is an equation that relates the variables. Now, if we solve for y here, for example, if we have 2x plus y equal to 4, if we solve for y equal to negative 2x plus 4, of course those are exactly the same, but this is implicit and this is explicit. Also, when we have x times y equal to 5 and divide by x on both sides, we have this. So this and that almost the same. The difference here is we cannot divide by 0. So x cannot be equal to 0. Over here, x still can be equal to 0 when we have the equation. So that is implicit and explicit forms of a functional equation. Next block we have different quotient. So this is similar to Cauchy algebra. So different quotient is that formula. Of course, the function will be given. So this example, let's find different quotient for the following function. So we start with the formula. f of x plus h divided by minus f of x divided by h. And that will be equal to. So first thing, this is the function f of x equal to 2x minus 2. So if I write the function be like that. Whatever I put inside the parentheses here for the function, I will replace on the same parentheses on the other side. So it doesn't matter what I put here, it will go there. Let's say if we put this simple, for example, then we will do the same thing. Yeah, whatever we put in the parentheses, we do that for every x in that equation, right? Now first, we're going to put x plus h inside the parentheses, meaning we'll replace into this every x into the equation. So that will be 3 times x plus h. So we'll replace x plus h into every x of the equation, which is that, and then we still have minus 2. So we'll have that minus f of x, or f of x is just original function, divided by h. Now, multiply it out, remove the parentheses or the bracket, 3x plus 3h minus 2, and then minus 3x minus a negative turn to a plus. Now what we see here is that we have 3x cancel with negative 3x. The negative 2 cancel with 2. So we just have 3h over h. And then the h cancel out. We have 3. Right. So the difference quotient for that function is 3. Simple enough, right? Right. Let's try a few more. The function different quotient f of x plus h minus f of x all over h. Right, first f of x plus h. So what we do is we will substitute x plus h into x here. And then subtract f of x, which is the original function. All of that over h. So we'll try to simplify this. So when we simplify the square root, I think this partly in trigonometry, when we try to simplify the square root, we can multiply by the conjugate. So what we do here, if we don't want to get rid of the square root, we multiply by the same thing. X plus h plus 1. It's going to be plus square root of x plus h. Yeah. So multiply the top and bottom by the same thing, which is the conjugate. So if it is the minus, multiply by the 1 with the plus. Those are called the conjugate. Right now we multiply it out. Square root times the square root, we just have the square root square. And that square root times that square root, so we have 2. And then subtract. and that times that will be minus square root of x plus h, sorry, this will be 1, right? I just copied it wrong. Yeah. F of x is the original function. Sorry. Yeah, that's just the function. And all of that divided by the bottom. The question is, should we multiply this out? Well, for now, I'm not going to multiply this out. And the answer y will come after we do this one. Once again, sorry about that. Right, now, this is a plus. There's two different square root. Those middle term cancel out. Right? We know that for sure because that's why we multiply by the conjugate. A plus and a minus. In general, what we have is when we multiply by the conjugate, we have a squared minus b squared. So the middle term cancel out. Right, so we have that. Now, square cancel the square root. We have x plus h plus 1. Once again, square cancel the square root. At the bottom we have h times square root of x plus h plus 1 plus square root of x plus 1. Right, now we can remove the parentheses. X plus h plus 1 minus x minus 1. The bottom we don't multiply it out. We have x cancel with x, 1 cancel with 1. We just have h on the top. The bottom is h. And then we cancel the h. So just have 1 over square root of x plus h plus 1 plus square root of x plus 1. Right. Now, to go back and answer why we did not multiply this out at the denominator. Well, to do that, we look on the big picture of this two problem. What we see here is we will cancel. That will be a lot to cancel out. Just leave an h on top, and the h that will cancel with the h at the bottom. That usually be the case. If the different quotient to do it correctly, usually there will be two common steps. The first one is that we cancel everything without an h, and then we cancel the h at the bottom. Usually we have those two steps. So I just write out the common step. The first one is cancel everything without an h. Usually it cancel everything without an h. That step on the top. Cancel terms without h. So here the 3x cancel with 3x, the 2 cancel with the 2 because they do not have h, and they cancel out. The second step that should be there is the step where we cancel the h at the bottom at denominator. So if we do this correctly, we usually see these two steps in the difference quotient problem. So just like this, we see we have the x, cancel the minus x, the 1 with the negative 1, they cancel out because they cancel out. So the term that does not have x, does not have h, cancel out. The terms without h got cancel out. So we will have with h on the top. The h on the top we cancel with the h at the bottom. So we have those common steps in this problem. Right, so that is that problem. Next, we do find a different quotient for this function. So difference quotient f of x plus h. So we will put x plus h into x. So we have 2 over x plus h, and then minus f of x is 2 over x of that over h. So what we're trying to do is try to cancel everything without an h, and then what's left we'll cancel with the h at the bottom. Right, but first let's try to simplify things by at least try to simplify the fraction on the top. So to do this, we multiply the top and the bottom by something that will cancel out the denominator. Usually if we multiply by something that cancels the denominators, it would be the least common denominator, and that's exactly what we do. So we multiply by the least common denominator of x times x plus h, top and bottom. So we multiply that to every term, pretty much. X plus h, and then we'll multiply x plus h minus 2 over x times x plus h, because we multiply to the bottom as well. Right. So when we multiply the x plus h and x plus h cancel, and the x here cancel with this x. So we just have 2x minus 2, and then that cancel out, we have x plus h all over hx, x plus h, multiply it out on the top, 2x minus 2x minus 2h over hx and x plus h. And then you say, why don't we multiply out the denominator? Well, the same reason as we don't multiply the denominator there, because we want to cancel the h at the bottom. So that's why we want that to be by itself here. And the usual step, cancel the terms that do not have h. So we just have negative 2h, and then the h and the h, let's just write one more step, 2h over hx, x plus h, and then we can cancel out an h. So we just have with negative 2 on the top, at the bottom we have x plus h. So as you see, there are two common steps. Cancel the terms that do not have h, and then cancel the h at the bottom. If you do correctly, usually you have those two steps. Same thing, different quotient for this function. F of x plus h minus f of x over h. The difference here is that the function have two different places for x. So when we substitute, we have to substitute into all the x's. So we have negative x plus h, and plus 3 x plus h, right? Subtract the original function. Right, multiply it all out and remove the parentheses. Right, the negative x plus h. Just keep the minus for a moment. Now we have x plus h times x plus h. Multiply them out, x times x plus hx plus hx again, and then h squared. Combine like terms, x squared plus 2hx plus h squared. So we have negative still there, x squared 2hx h squared plus 3x and 3h minus negative. That turned into a plus, minus a plus, minus a positive, so minus 3x. All of that, sorry, divided by h. We get that at the bottom. Yeah, that's where we multiply now. This way. Right, now we move to parentheses. Negative x squared, negative 2hx, negative h squared, plus 3x, 3h, plus x squared, minus 3x, over h. Now, this term does not have h, so that should cancel with something, and it does. This one has an h, that's more likely we stay. That one has an h, that will stay. 3x, this one does not have x. This should cancel with something, and it does. So we're left with those negative h to hx, negative h squared plus 3h, all of that over h. All of them have h, so why don't we factor it out? Negative 2x, negative h. We only factor out the h, we do not factor out the negative, even though we still can, but I don't want to do that. Yeah, just factor out the h. So negative 2x, negative h, plus 3. Cancel the h at the bottom, the usual step, and we end up with negative 2x minus h plus 3. Right, so that is the few example of the different quotient that I want to do. Next we have domain of some common functions. So this of course is just in Quotient algebra. We have this already. So domain of some common function. We start with the set of all real numbers. Now, if there is the denominator cannot equal to 0, so we just say denominator because we cannot divide by 0. Right, denominator is at the bottom cannot equal to 0. Now if we have an even root, then we exclude any number that causes the expression that inside the radical or inside we call the radicand to be negative. So what we can have inside even root, what we put here have to be greater than or equal to 0. Otherwise it will be undefined. An even root of a negative number is imaginary or complex number, so that it's not real. Right, so let's look at this example. Find the domain of this function. So by default, domain is all real number unless we have the denominator that is not equal to 0, unless we have something inside the even root that is greater than or equal to 0. In this case, we do not have either of those two real numbers. If we're going to write, it's going to be the whole number line. Or if we use the notation, interval notation, that will be negative infinity to infinity. So could be all real numbers, that number line, that whole number line, and the interval notation, negative infinity to infinity. So that is the domain of that function. Now this function, what we have is an even root, the square root. So the rule says whatever inside the even root have to be greater than or equal to 0, because we cannot have negative inside the even root. That could be imaginary. Right. Yes, easily, just plus 2 on both sides. We have x greater than or equal to 2. Now, if we want to write the domain, we can write just like this. If we want to be more precise, we say x such that x greater than or equal to 2. So this means the set of all the x such that x is greater than or equal to 2. So that we write the domain like that. Or if we use the number line, it will go from 2, because it has the equal sign, so we use the parentheses. We use the bracket if it has the equal sign. If we don't have the equal sign, we use the parentheses, meaning that we use the parentheses. It goes from 2 to infinity. That is the interval notation. Right, next, what we have here is we have the denominator, and the denominator cannot be equal to 0 because we cannot divide by 0. So we have 2x minus 5 not equal to 0. Of course, we add the 5 on both sides. We have 2x not equal to 5, and then divide by 2. So x is not equal to 5 over 2. So of course we can just say the domain is the set of all the x such that x not equal to 5/2. Or we use the interval notation. By the way, let's just draw it first. Yeah, it could be anywhere except for 5/2. It could be on the right, it could be on the left, but cannot be at the 5/2. So we say negative infinity to 5/2. And then union with 5/2 to infinity. Right? So, yeah, of course, or we can just say the set of all the x such that x is not equal to 5/2. Yeah, any of this will work. Right, next, we have this. The denominator cannot equal to 0. So what we say is the denominator cannot equal to 0. And they will just simply solve for x. Move the 4 over. And when we take the square root on both sides, don't forget there is a plus or minus. So if x not equal to plus or minus square root of negative 4, regardless of whether we have the plus or minus or not, that's not really important. What important is that we have negative inside the square root, which is not real, or just say imaginary. Of course, meaning that not real. And the domain when we talk about is only the set of real numbers. So in this case, because it is not equal to something that is not real, so not and not So we have double negative here. X is not equal to something that is not real, meaning any real number will work, because a real number certainly is not equal to an imaginary, right? So in this case, the domain will be just all real numbers, because the real numbers for the domain is not equal to imaginary. So that makes perfect sense there. So all real numbers. And that's all we have. Of course, all real numbers we can also write using this notation, negative infinity to infinity. And we select the whole line. That's all we have. Combination of functions. Now, we have f and g be two functions. Then when we add two functions, we just add two functions, pretty much. Subtract, multiply, or divide. Rather obvious, right? The only difference here of this is we cannot divide by 0, which of course divide by 0 is undefined, so we never do that. Right. So now we have some example here. F plus g of x. So just say f of x plus g of x. And f of x is 2x plus 5 plus g of x is x squared minus 5x. Yeah, just put the parentheses around them. Now remove the parentheses and simplify to x plus 5 x squared minus 5x. Right. Combine line terms, 2x minus 5x. So x squared minus 3x plus 5. Right. Next, whether it is x or any particular number, we do the same. Just say f of 3 minus g of 3, meaning that we're going to put 3 first into the function and then subtract them. F of x is 2x plus 5, so we're going to put 3 in for x here. So that is f of x at 3. Yeah, put 3. And then g of x at 3, we're going to put 3 in here. There are 2 places for x, so we have to have 2, 3. Right, and that gives us 11. And then 9 minus 15 minus 6, and that is 17. Of course, let's use a calculator. Right, we just have 3 stored to x. And then we have this one, 2x plus 5 give us 11. And then x squared, or we just type xx minus 5x. And we have this, subtract that number, 17. Right. Now f times g of x, that means we just multiply them. F of x times g of x. F of x is 2x plus 5. G of x is x squared minus 5x. Now multiply it out to x times x squared to x cubed to x cubed times this will be minus 10 x squared plus 5x squared minus 25x. Right, combine like terms and let's just put them in decreasing order. Yeah, that gives us minus 5x square and then minus 25x. Right, let's check to execute. Minus 5x square and minus 25x. Now, h over k of x. It's just h of x over k of x. Of course, k of x is not equal to 0. Now we just substitute in x. H of x is 2 over x. And k of x, 2 over x plus 4. Yeah. So h over k. Now, divide fraction is multiply reciprocal, so we're just going to flip the second fraction. And then we cancel out the 2. Just have x plus 4 over x. Right, so that is one way to do it. The other way to simplify it is where we have 2 over x over 2 x plus 4. Right, if we want to simplify fraction, we can multiply by the common denominator. In this case, the denominator will have x and x plus 4. So we multiply by x times x plus 4, top and bottom. Plus 4, right? Right here, the x plus 4 cancel out. And the x and this x cancel out. So we just have 2 times x plus 4 on the top. And x plus 4 cancel out 2x at the bottom. Cancel out the 2. We have x plus 4 over x. Oh, actually this is the end of section 1.1. So I stop the video here. Thank you for watching.